So consider a sphere of radius 10 centimeters, right? This is not in your notes, so we will just explain this part from yesterday, right? If there's a radius change of 0.1 centimeter, which is a very small amount, how much was the volume change? Well, we take the derivative of our volume, right? Get 4 pi r squared dr, because the derivative of r cubed is 3 times r squared dr, right? Because r changes as a rate. And then we plug in our 10 centimeters for our radius, and our 0.01, because that is the change in radius, dr, that represents a change. And we come up with 40 pi centimeters cubed. Now, the only difference between that and this dude blowing the bubble is now I want to find an instantaneous rate. That means my derivative's got to be with respect to time. Okay? Because it's an instant that it happens. Remember when we did that difference quotient? And we had an h on the bottom of it, and h going to be 0. We had to expand the top. Well, when h is 0 at that instant, right, we had to kind of find a way to get rid of the h. It was complicated. We learned that it was just derivatives. Okay? So the same thing applies here. And the steps really aren't that different. Okay? Here's the volume. Okay? V. dV is the derivative of the volume. It's the volume, the change of volume with respect to time. But now the radius, dr, the change of radius, has also got to be to time, compared to time. That's it. So we still throw in our 10 centimeters, still throw in 0.1 for our change in radius, and we still get 40 pi centimeters cubed, but now it's per second. Okay, it's that exact moment per that second. Not just the overall volume, but it's overall volume at that second, okay, per second. So that's the rate the sphere is growing, and this is an exact answer. It's not an approximation, like we did with differentials yesterday. All right, and we're going to kind of move forward with this, okay? 4.6 is related rates. We can differentiate an equation that relates two variables with respect to time. Just like that bubble can do. Okay, to find out how the rates are related. Example 1. The radius of a sphere is decreasing at a rate of 0.5 centimeters per second. What is the rate of change of its volume when r is 20? Who knows the equation for the radius of a sphere? Yeah, didn't we just see it somewhere in the first slide or two? Thank you. Volume of a sphere, 4/3 pi r cubed, because area is squared, volume is cubed, right? So we are going to say that the volume is 4/3 pi r cubed. Now, they want us to find the rates of change of volume. So we need to find dV with respect to time. Okay? Well, let's take the derivative. All right? I'm going to have 4/3 times my pi. That's a constant. I can just leave that out and take the derivative of everything else. Now, what's the derivative of r cubed? It is 3r squared times that small change in rate of the radius over dt, because it's the change in radius with respect to time. My two variables are v and r. I'm just, when I take the derivative, I'm just putting them over dt. This is really nothing new. Okay. So let's clean this up a little bit. Okay, this 3 cancels with this 3. Okay. And we now have 4 pi r squared dr dt equals dv dt. Well, what does it give us now? It says we want to find the radius of a sphere. The radius of the sphere is decreasing at a rate of 0.05. What do think that represents? It is dr. This is what we want to find. They give us dr dt, which is negative 0.5. Negative simply means it's decreasing. When we get our answer that's negative, we just say it's decreasing. Okay? And what else do they give us? Right at the moment, our radius is actually 20. So now, guess what I'm going to do? 4, so 5. My radius is 20 when I'm squaring, and my dr dt is negative 0.5. Someone give that to me, but leave the pi in there. We'll leave it in terms of pi so it's exact. We're not going to round 3.14. So just leave the pi in there so the answer will be 10 pi, 13 pi, whatever. In the, so it is, so what's that at? Negative 800 pi. And guess what? This is centimeters cubed per second. Yeah, this is 400 times 4, which is 1600. You take half of 1600, it's 800, and it should be negative. Now, your answer, you don't want to say it's the value is changing negative 800. When you have this, you just want to say it is decreasing at a rate of 800 centimeters cubed per second. All right? It's a hot air balloon. So, example 2, the hot air balloon problem. Given that pi over 4 is what theta is, right here. That is our pi over 4. And the change in theta is 0.14 radians per minute. Okay? How fast is the balloon rising? So we need to find the change here. We need to find dH. Okay? That's what we need to find. So as this changes and gets higher and higher, right, shouldn't H rise? It makes sense, right? But what we need to do is how can we take theta, H, and 500 and create an equation? Yeah, you're going to use trigonometry. So based on this angle right here, what sides do I have? I have the opposite side and the adjacent. Tangent. The tangent of my theta is going to equal H over 500. Because tangent equals opposite over adjacent. That's how I got this. Okay? Now, if I want to figure out dH, in this case, wouldn't it be easier if I got the H alone? Yeah. And then I can see the derivative of H and it equals whatever the equation is. We can do that. We can manipulate it anyway. You could proceed this way. It'd be a little bit tougher, but you could. You take the derivative of tangent of theta and then do the derivative of low d high minus quotient rule. But let's make it simple. Okay? If I could cross multiply, H equals 500 times tan of theta. That is a lot easier to take a derivative of. And there's no quotient. You don't even have to do product rule here. Because 500 is constant, so leave that alone. And derivative of tangent, and throw that back in. So my dH. Now, you should get in the habit with respect to time. I like to save space in writing. I don't write it. I just put it on the label in the end. You should get in the habit of this. Equals 500, because that's a constant. What's the derivative of tangent? Secant squared. Now keep in mind, it's secant squared of theta times the derivative of whatever the inside is, right? That's just d theta over dt, because it's with respect to time. All right? And what two pieces of information did they give us? They gave us theta, and they gave us the change of theta. We're just going to plug those in. That's what dH is. Okay? So we have 500 times the secant of, secant squared of pi over 4 times, and what is the change in theta they give us? 0.14. They don't have a secant in the calculator, do they?
1 over cosine.
It's 1 over cosine. So that's the same as saying, for the purpose of our calculator, as I write this, you guys want to type this out, it is 500 times 1 over the cosine of pi over 4. Don't forget, it's all squared, because it's squared, times 0.14. Someone tell me what you get right there when you do that. The answer is always T. But for this problem, we're going to veer from that. Okay, what do we get? What do we get? Maybe. Let's check this out. Make sure you're in radians, because that's radians. Okay? So if I go to mode, I'm in radians. Good. So I'm going to clear this out. I'm going to say 500 times. I'm going to put my fraction here, because it is 1 over the cosine. I'm going to do a fraction here. And I'm going to put pi over 4. Bang. Close that bottom parenthesis. Close the parenthesis for the fraction, but that's squared. You've got to be squared. Times 0.14. 140. 140. Which means, okay? Which means it's no, wait. 140. That is the change in heights. But what is it? Does it give us a? How fast is the balloon rising? Just 140 units per minute. Oh, what are our units? Right there. So it's 140 feet per minute. That means every 60 seconds you're going up another 140 feet. Example 3, the truck problem. Okay? It says that truck A is traveling east at 40 miles per hour, right? This is truck A. It says truck B is traveling north at 30 miles per hour. This is truck B. Okay? How fast is the distance between the trucks changing 6 minutes later? This is the distance between the trucks. We'll call that, well, A, B. We'll just call this C. Now, I have a right triangle. What do you think we're going to use if I have two sides? Use what? Let me do it this way. No. Yeah, don't we need to use, if we're going to find a hypotenuse, we have two sides? The Pythagorean theorem. Pythagorean theorem, all right? So that is a squared plus b squared equals c squared. But a isn't 40, b isn't 30. This is actually the change of a. It's moving. That's the movement. This is actually the change in b. But here's a question. How can I figure out those sides, actual distance, at 6 minutes? Yeah. Yes. 6 minutes. Are there 60 in an hour? So isn't that 1/10 of an hour? So it's driving 40 miles an hour. What's 1/10 of 40? That means in 6 minutes, If it's going 40 miles an hour, it would go 4 miles. Okay? Because 1 times 40 gives me 4. What is 1/10 times 30? 3. So this side is actually 3 miles. Okay? Now, yes, this might be 5 miles, but they want to know how fast is the distance between the trucks changing. They don't want to know the actual C, they want to know DC, the actual rate. So, with the Pythagorean theorem, 3 squared plus 4 squared, isn't that 5? C squared, so C would be 5. Okay, so if I actually did 3 squared plus 4 squared equals C squared, that's 9 plus 16 equals C squared. 25 equals C squared, 5 would equal C. Okay? They don't want C, they want that rate of change. So guess what? I'm going to take the derivative of my Pythagorean theorem. Okay? 2a times dA, right? Everybody get that? It's 2a times the dA, times the derivative, right? Or whatever a is. Plus, what comes next? 2b times dB equals 2c times dC. They want to know dC. Well, I tell you what, the first thing I'm going to do is DC, I'm going to divide both sides by 2. Because if I divide everything by 2, what happens? Yeah, 2's go away. Don't got to worry about it anymore. So now I have A dA plus B dB equals C dC. That's not an E, it's a C. Okay? All right? Well, don't I have some numbers to plug in? What's my A value? 4 is the A value. 40 is the rate of change for A. Okay? So it is 4 times 40 plus, what's my B and my rate of change for B? 3 is my B value. 30 is my rate of change at 6 minutes. So it is 3 times 30 equals, what's my C value? 5, and I want to find, so when I do, what's 4 times 40? What is 3 times 30? What happens when I divide both sides by 5? What is 160 and 90? 250. What's 250 divided by 5? The hypotenuse is changing at 50 miles per hour. No, it will not always work nice and easy like that. For this one, because they're Pythagorean triples. 3, 4, 5, 30, 40, 50. Worked out. It would work the same way. That's the beauty of it.